Hi all, this is Sangeeta from VSP Engineering College, Karur. In this lecture, we will be discussing about joints and connections in structural members, which is in Unit 4 in prefabricated structures. And the objective of this unit is to acquire knowledge about joints and connections in precast construction. And in this unit, we will be dealing with the types of joints, which is classified based on the action of forces into compression joint, shear joint, and tension joints. And based on the function, it is classified into construction joints, contraction joints, and expansion joints. And design of expansion joints, including its dimensions and detailing, and the types of sealants and types of structural connections, that is from beam to column, column to column, beam to beam, and column to foundation. So what is the precast reality is shown in the figure, and the monolithic illusion is shown in the figure. And precast components are inherently an isolated structural elements. That is, they are manufactured as a separate units in a different site. Structural integrity relies entirely on the joints and connections to transfer moment, shear, and axial loads. The goal of the prefabricated components or the structures is to mimic cast in situ monolithic performance, which the help of joints and connections. So the figure helps you to understand how the monolithic construction will be there, and the precast components will be assembled. And the classification of structural joints, they are classified as discussed earlier based on the action of forces into compression. And these compression forces is mainly due to gravity and axial loads, and shear forces, which is due to lateral and sliding forces, and tension forces, that is pull apart forces. So these are the classification of joints based on action of forces, and based on function, it is classified into construction, that is phasing of force. Next, contraction joint, which is due to curing and shrinkage, and expansion joints, which is provided for the purpose of thermal and environmental moment. So these are the joints which are classified based on function. So this slide gives you the information related to transferring of gravity loads through compression joints. Here for the transfer mechanism, we use high strength non-strength grout or mortar bed. The concrete to concrete contact causes localized stress concentrations and spalling of concrete. The mortar bed ensures uniform stress distribution across the entire cross section. And the primary application of this joint is used for column to column splices and load bearing wall to panel connections. And the design rule used for the gravity load compression joint is that it must possess compressive strength equal to or greater than the connected precast member, so that it can efficiently carry the load transferred from the one above column to the bottom of the column. Otherwise the joints may fail, resulting into the failure of the entire structure. And the joints which are used for resisting lateral sliding, as discussed earlier, is the shear joints. And the shear keys are provided, that is the mechanical interlocking is provided, which significantly increases shear capacity beyond mere surface friction. And the mechanism involved in this joint is the force is transferred via diagonal compression struts formed within the grout keyaway. The primary application of shear joint is that it is used in shear walls, diaphragm slabs, when subjected to wind or seismic lateral loads. So the next type is tension joint. Since concrete cannot reliably carry tension, because the concrete is strong in compression but weak in carrying tensile forces, so it requires alternate method of load transfer. And the solution for this alternate method is the tension forces must be intercepted and transferred directly or entirely through steel reinforcements, that is lapped bars, welded plates, or post-tensioning tendons. The primary application of this type of tension joint is bending moments at beam column nodes and tie forces in the large panel systems. The figure shows you the transverse locking bar and interlocking rebar loops, which gives you the schematic representation of the tension joint which is used. The next type is construction joint, and it is otherwise called as cold joint. It is created intentionally where concrete pour has to be stopped for the day or suspended for the day, and it is designed to allow the next pour to bond properly in the next day process. The figure shows you the how construction joint is practically applicable. And the next joint is contraction joint, which is otherwise called as control joint. It is induced to accommodate the volumetric shrinkage of concrete as if cures. It forces the inevitable cracking to happen in a neat predetermined straight line rather than randomly. So that is the tool groove which is shown in the figure, and the crack which is available in the component. So the next joint is expansion joint. And the expansion joint is provided because buildings continuously change volume due to seasonal temperature fluctuations, moisture variations, and long-term creep. Without an expansion joint, this movement induces massive internal structures, leading to structural buckling, severe spalling, and uncontrolled failure. The thumb rule is to provide or completely separate the structural frame at a specified intervals with the help of some gaps or joints provided typically at an interval of 30 to 45 meter depending on the system. And the expansion joint is taken as compressed gap in summer season, and the contraction joint is provided, that is in the form of stretched gap during winter season, and a neutral or standard gap is provided, and these such joints are provided to avoid the structural deviations due to seasonal variations. So this figure shows you the dimensions and detailing of a joint. It consists of a joint width, which is the total gap between the two concrete faces, denoted by the symbol W, and capital D, which is the thickness of the material, called as sealant depth, denoted by capital D. And the rule says that is the W is to D ratio should be within a range of 2:1 for ideal elastic performance. That is, if W is 20 mm, then D should be 10 mm. And the next one is backer rod is provided for the joint, that is a circular foam tube wedged beneath the sealant, controls the depth of the sealant and provides a firm tooling surface. And the last one is the bond breaker, crucial detailing ensuring the sealant only adheres to the two vertical sides, not the bottom, preventing the three-sided adhesion effect. So these are the dimensions and detailing related to This slide shows you the chemical defenses, that is sealant comparison matrix. Polyurethanes moderate to high, that is of 25% movement capability, and for weathering it is good, and for adhesion to concrete it gives excellent, and for the lifespan of the sealant is 10 to 20 years, and for silicones the movement capability is extremely high and outstanding, that is unaffected by sunlight, requires primer, and it has a lifespan of 20 plus years. And the polysulfides has a movement capability of moderate, that is plus or minus 25%, and for UV weathering it is good, and addition to concrete it has excellent chemical resistance, and lifespan is 10 to 15 years. And this shows the anatomy of structural components. Beam to column connections, that is transferring floor loads to vertical supports, and second one is column to column, that is splicing the vertical spine that is connecting two column members, and the third one is beam to beam, this one creating continuous horizontal floor diaphragms. And the next is beam to column connections. The corbel, it is a monolithic bracket cast directly into the column face. So this is the corbel, which is a monolithic bracket which is connected into the uh, column face, and it has elastometric bearing pad which sits between the corbel and beam to prevent point loading and allows light rotation. So this is the elastometric bearing pad as shown in the figure, and the connection mechanism, a steel dowel ties the members together to resist moment and shear forces, locked later with grout. Standardized for industrial and commercial frames, providing rapid erection while ensuring positive gravity load transfer. The next one is column to column splices. Here we have protruding dowels, that is longitudinal reinforcement continuing from the lower column. Corrugated ducts, voids cast into the upper column to receive the steel. And the next one is grout tubes, that is injection ports where high strength non-strength grout is pumped into the connection, and shims, that is the small pads, that is small leveling plates ensuring perfect plumbness before the final pour. It is essential for multi-story precast column to column connection, must guarantee seamless load transfer, that is axial compressive forces and bending moments. The next one is beam to beam integration. DAPT, it creates a continuous horizontal floor diaphragm. Half lap connections maintain a flush bottom profile while supporting the heavy shear. And this diagram shows you the beam to beam integration component. And the next one is column to foundation grouting. The pocket, which is otherwise called as socket foundation, structural grouts lock the column perfectly without the overturning moments, grounding the structural moments into the earth. So this is the pocket connection setup. And the next, so this slide shows you how the fragile parts are combined to give a resilient performance. That is, though the prefabricated components are manufactured at a different site, they are assembled to a site where it is required, and they are transferred to a single monolithic structure with the help of joints and connections. If a joint and connection is not properly designed and carried out, the entire structure may collapse and it will not serve the purpose for which it is designed. So it states that the effective joints and connections are the true engineering achievement of prefabricated structures. They transform disparate blocks into unified monolithic frame capable of withstanding dynamic forces. So this is the gist of the unit 4, joints and connections in structural members. In the next upcoming lecture, we will be dealing with design for abnormal loads in prefabricated components. That is what happens when a monolithic frame faces extreme and unseen forces. Thank you.